All right, Mr. Solis here. Talking from AQR again, and we're going to be exploring a few things. Number one, I want to make sure before I get into the stuff for today that you understand that we have several different items. Like when to use line reg, exponential reg, and logistic. Now it depends on what you see. If what you see is what you get, WYSIWYG. And if you see right here under the first one line reg, you see a line, and with the dots. With the exponential reg, you see an exponential progression of the data, where it keeps on going up and up. And then logistic is basically it starts out slow, goes up exponentially, but then it tapers off and it starts declining, and then we reach this apex where it just starts kind of coasting and doesn't get any larger than a certain amount, and that's populations with limits right over here. We also have this new one, sine reg. Sine reg is used for sinusoidal waves, so we're going to be taking a look at that in this tutorial. So we have this little thing, we have length of daylight. We have several different cities. We have Houston at 30 degrees north latitude. We have Philadelphia, which is 40 degrees north latitude. Winnipeg, 50. And Porto Alegre, whatever. I can't pronounce things too well. So there, Brazil. So we have all these things. We have all this one, this one, this one, and this one. And we have a question. Which city do you expect to have more daylight during the summer, Houston or Philadelphia? So we're going to take a look at Houston or Philadelphia and all that. So, why do you think so and all this good fun stuff. So we're going to be exploring that later on. Now, number one, we have this data from Houston, and they've actually recorded this during the year. So they first went with the first of the month, and now it's let's see, they give you the day number, which is right here, which is going to be our X, and we have this a full amount of data throughout the year. Notice that it doesn't go beyond 365 because there's 365 days in one year. Good reason. Then we have this one right here, which is the number of minutes. Number of minutes are basically going to be our Y, and we're going to be mapping this data. It's easier than using the hours and minutes that they give us, but at least we know the minutes that the sun is up on these particular places. 1, 2, 3 is using graphs, and you're actually going to have to do this. So this is the first one. This is for number 1. This is the actual graph right here. So it gives us this graph if we go ahead and do a scatter plot of the data. And we're going to go ahead and explore that a little bit later on. So I'm going to go ahead and teach you guys a few things. So we're going to start with the first part of our directions, create a scatter plot. And what we're going to do is basically use this piece of paper that I'm going to give you. It's going to have a basic graph on it. Why am I going through all this? Well, we'll go ahead and look at that later. Don't worry about it. So we're going to go ahead and create this scatter plot that I'm going to give you. And actually, I'm going to go ahead and use the calculator to do this also. So you have to do it on the paper and using the calculator. Calculator is kind of easy. I've already added my data right here in the stat key. So to get there, we use the stat, which is a button that's right below the delete. Push enter to get the edit. And as you can see, I put the days in column 1, which is L1, and inside of L2, I put the number of minutes that the daylight is up. I'm going to hit zoom 9 to go ahead and take a look at the data. Oops, it doesn't show up. Why? Well, that's because I didn't turn on my plotter. So I hit second, Y equals, and I look right here, plot 1 is off, so I need to push enter and then turn on the plot. Now, if we hit zoom 9, we should be able to see it. And there it is. We have all of our data given to us. And so, that's basically what we have here on this graph. If you look at number 2, enter the data into your stat list in the graphing calculator. We already did that. Step 3 is use the sinusoidal regression model, record the equation, round to the nearest hundredth in the summary table at the end of this sheet. So we're going to be doing that real quick. So I'm going to go ahead and hit stat, calc, and I'm going to go ahead and look for sine reg. There it is. It's actually under C or whatever you want to say it, but just look down. It's under logistic, which we should explored last week. So let's go ahead and hit signreg. I can go ahead and take the formula and store that into my Y table. So I'm going to do that real quick. And the way I do that, I hit the vars button, which is right next to the clear. Go to yvars, go to the right one, and I look for function, and I want y1. Hit enter. Now the only thing that's different between this and the other one is the fact that I need to go ahead and tell that the other calculator and that it's under store reg, and it'll just go down there, and that's where you're going to put the y1. So let's see what this has. So we're going to go down, and there it is. And I actually wrote this down earlier, and as you can see, this is everything. This is the raw data. Now here's the thing, let me go ahead and erase this just so I can go ahead and write this out. When you go ahead and take the data from the calculator, round to the nearest hundredth, which is like right here we have 113.259, so we're going to round to the nearest hundredth, so it's 26, and we have that right here, and then we're going to write this out. So of course we have our A, this is our B, this is C, and this is D. But according to the instructions right here, if I go ahead and look back, use your calculator, factor the value B from the quantity B x minus C. So we're going to go ahead and factor that first. So we're going to factor out the B, which is right here, 0.017x, and we're going to go ahead and factor it out from there. So we're going to end up with y equals to 113.26, so that doesn't change. Sine 0.017, and we're going to make a new open parentheses x minus, now since we factored out 0.017 from here and from here, we're going to have to factor that 0.017 from 1.32. So we're going to 1.32 divided by 0.017. This is factoring it out, and it gives me 77.64, which is 77.65. Let me write that in another color. 77.65. Close parentheses, close, plus, and we have to write down our D, which is 727.37. So now we have this factored form, and you're going to write inside of this table right down here. This table right over here. And as you can see, I already wrote this one out. This is the calculator form. That's the raw data before I do the factoring, and here's the factors. Now, they want us to do several other things. They want us to go ahead and graph your model over your scatter plot. How well does it fit? You know, you can answer that inside of class. Connect the points in the scatter plot with a smooth curve represent. Use your calculator to determine the maximum and minimum values of the length of daylight in Houston. Record these ordered pairs in your summary table. So we're going to go ahead and do this real quick. Right here. So I have our maximum minimum, but I want to show you how to go ahead and calculate that. I go back to y equals. Everything's already in there. Although I could have just went ahead and put in the factored B form into the y1 and put it in manually, but you know, this is a little bit faster. So I hit graph. There it is. All right. Now, as you can see, the peak is our maximum. So I'm going to go ahead and find out the coordinates for my maximum. Let's see. So I'm going to go ahead, number one, I'm going to start by hitting second trace. And this will bring up this menu, and I want maximum. Now, I need to do several things. Let me use the other chart to go ahead and do it. This is where the maximum is. So I need to pick points to the left and to the right of the maximum. So I'm just going to go ahead and I'm just going to pick some numbers. Left bound, let's see. Let's just move this to the left. And as I'm hitting the left button, it's just moving the cursor on the screen. I'm going to hit enter. That tells it that's the left bound. And now I'm going to go ahead and go to the right of the maximum. And I'm just hitting the right button, and there it is. And as you can see, this is my this is in between. So what the calculator does, it starts calculating all the y's and saying, all right, that's not a max. This is okay. Which one of these y's are maximum? And then it'll just go ahead and give us the calculation from there. And you push enter again so you can go ahead and find the maximum. So now the maximum is at 172, and that's 841, and that's right here for this ordered pair, which is right here. Now, this date happens to be June 21st. Length of daylight, 14 hours and 1 minute. Now, to get the length of daylight, it's pretty easy. All I do is just this. I just go ahead and take 841 divided by 60. That's 14 hours. I subtract the 14, then I multiply by 60 on the remainder, and that gives me 1. So it's 14 hours 1 minute. I do the same for the minimum, except now when I graph, I'm going to have to go ahead and use second calc, and I look for minimum. There's a minimum right there. I'm going to go to the right because I want to go ahead and go all the way to the right because my minimum is right over here. I'm using the mouse, that way you can see it. So I'm going to go ahead and pick a point to the left in the minimum, push enter, and then I'm going to go a little bit further out. I'm going to try to go as far to the left as I can. There we go. That's as far to the right. I get my left and right confused all the time. And now I push enter, and now I'm going to do the calculation. And that says 359 and 614, which is right here, 359 and 614. Find out the time, 614 divided by 60. That's 10 hours. I subtract 10 because that's the leading number, and I multiply by 60 on the remainders to go ahead and get my minutes, so 14 minutes. And that's it for that. So what you're going to be doing is more of this. You're actually going to be doing something a little bit more, which I'm going to have to go ahead and make a second video because I'm almost out of time on this one. So remember to watch part B. This is part A, and I'll see you later.